An anti-radiation missile is a missile designed to detect and home in on an enemy radio emission source. Typically, these are designed for use against an enemy radar, although jammers and even radios used for communications can also be targeted in this manner. Air-to-surface. Most ARM designs to date have been intended for use against ground-based radars, commonly carried by specialist aircraft in the suppression of enemy air defenses role. The primary purpose of this type of missile is to degrade enemy air defenses in the first period of a conflict in order to increase the chances of survival for the following waves of strike aircraft. They can also be used to quickly shut down unexpected surface-to-air missile sites during an air raid. Often, SAAD escort aircraft also carry cluster bombs, which can be used to ensure that, after the arm disables the SAM system's radar, the command post, missile launches, and other components or equipment are also destroyed to guarantee that the SAM site stays down. Early arms, such as the AGM-45 Shrike, were not particularly intelligent. They would simply home in on the source of radiation and explode when they got near it. SAM operators learned to turn their radar off when an arm was fired at them, then turn it back on later, greatly reducing the missile's effectiveness. This led to the development of more advanced arms like the AGM-78 Standard Arm and AGM-88 HARM missiles, which have inertial guidance systems built in. This allows them to remember the radar's direction if it is turned off and continue to fly towards it. Arms are less likely to hit the radar if the radar is turned off shortly after the missile is launched, as the longer the radar is off, the more error is introduced into the missile's course. The alarm even has an added loiter mode, with a built-in parachute, enabling it to descend slowly until the radar lights up, when the rocket motor will reignite. Even a temporary shutdown of the enemy's missile guidance radar can be of a great advantage to friendly aircraft during battle. Surface-to-surface. Several surface-to-surface missiles, like the HORMOS, P700 Granite, P500 Bizalt, MM40 Exocet, B611MR, and Otomit. This makes these missiles significantly harder to defeat with ECM and distraction countermeasures, and makes the use of semi-active missiles against him dangerous. Surface-to-air. Due to experiences with jamming by US-built aircraft in Vietnam and during Middle Eastern wars in the late 1960s, the Soviets designed an alternative tracking mode for their S-75 missiles, which allowed them to track a jamming target without needing to actively send out any radar signals. This was achieved by the SAM site's radar receiver locking onto radio noise emissions generated by aircraft's jamming pod. In cases of heavy jamming, missiles were often launched exclusively in this mode. Ironically, this passive tracking meant that SAM sites could track targets without needing to emit in any radar signals, and so American anti-radiation missiles could not be fired back in retaliation. Recently, the People's Republic of China developed the FT-2000 system to counter AEW and AWACS targets. This system is based on the HQ-9, which is in turn based on the S-300 PMU. These anti-radiation missile systems have been marketed to Pakistan and various other countries. Air-to-air. More recently, air-to-air arm designs have begun to appear, notably the Russian Vympel R-27P. Such missiles have several advantages over other missile guidance techniques. They do not trigger radar warning receivers, and they can have a longer range. In the 1970s, Hughes Aerospace had a project called BRAZO, based on a Raytheon AIM-7 Sparrow. It was meant to offer an air-to-air capability against proposed Soviet AWACS types and also some other types with extremely powerful radar sets, such as the MiG-25. The project did not proceed.